Topic 9-4. This can be referenced in our Holt textbook, Chapter 9, Section 1, page 591 through 592. The areas and perimeters of rhombi. Rhombi would be plural for the definition of a rhombus. So I went ahead and put some of my snap legs together. It's a quadrilateral with all four equal sides. What I want you to notice is that it would be a square if the sides were all perpendicular. But all we would do is swing it one way or the other, and that square then becomes a rhombus. So it is a four-sided quadrilateral that now has turned into a different shape than a square, but some of the properties of a square. So let's learn about what we know about diagonals of a rhombus. They are perpendicular and they bisect each other. So drawing of this square, it looks like a square, but you could also consider it a rhombus, and we can take the diagonals of each of these. I'm going to connect those and go ahead and label them. One would be diagonal 1, and then this one could be diagonal 2. So you've got two diagonals. Each is half the height of one of the other triangles. So when it says it cuts them into congruent parts, this diagonal now has congruency with this line, and diagonal 2 is bisected. I'll use 3 tick marks since 1 is already used for the outside. So this shows that from this point to this point, those are also the same length as this to this point. Alright, to calculate the area of just the triangle ABC, so if you were just looking at ABC, you know that you would take the diagonal, which is now the base, times this, which is the height, a portion of the diagonal 2. Same thing for calculating ADC, you would do the same thing, half of base times height. Those are the formulas for one triangle. You've just now put two triangles together. Here's how the formula of a rhombus is derived, and the formula for area is half of the diagonal 1 with the diagonal 2. We can go through this together if you'd like to see exactly how that formula was derived. Okay, the area of a rhombi is half of the diagonal 1 times times the diagonal 2. So you can multiply the two diagonals together and divide by 2. It's the same thing as multiplying by a half. To get a perimeter, of course, you would just be adding up all the sides, or say 4 times the sides, since all the sides are going to be the same. In the first example, you want to indicate the measure of each of the following rhombi. They want to know the diagonal. So if this measurement is 2 and this is 2, this diagonal 1 would be 4, this diagonal 2 would be 10. The area is taking the two diagonals, multiplying them together and dividing by 2. So your area would be 20. To get the side length, you're going to need to use Pythagorean Theorem. So I just took one of these triangles and transposed it out here. Knowing the two short legs was 2 and 5, use Pythagorean Theorem, square both sides, and then take the square root. So you would have the square root of the 29, which can't be simplified, so just leave it. The perimeter is 4 of those, 4 times whatever one side length is. So 4 square roots of 29. On this one, you might want to use a template you could borrow from your teacher and draw a rhombus. And then we're going to label it. If this whole diagonal is, we'll use this one, 4, then this would be a 2 and a 2. If this entire diagonal is 6, then this can be broken into 3 and 3. Our purposes for needing it broken into its bisected parts is to find out this side length. We know each side length has to be the same. You can show that with one tick mark all the way around. So multiplying the diagonals for the area and dividing by 2 leaves you an answer of 12. So 12 units squared would be the area, and then the side length you're going to take the Pythagorean theorem, 2 squared plus 3 squared. That's going to give us, well, let's see, our c squared. 4 plus 9 is 13. So 13 is our c squared. Always making sure you take the square root to get the c by itself. So c by itself is square root of 13. And again, if this one side is 13, then all square root of 13, all of them would be. So the perimeter is 4 times square root of 13. Okay. Example 3. The area, you're taking the diagonals. So 4 and 4 is 8. 3 and 3 would be 6. And divide by 2, you'll get 24. For the side length, again, you use Pythagorean theorem. This is a Pythagorean triplet you might want to memorize. If you've got a side length of a 4 and another side length of a 3, your hypotenuse is always 5. So 5 being the sides on the outside, although these were given to you. You didn't actually have to come up with it. So 5, 5, 5 would give us 20 for the perimeter. Okay, number 4. We know this is a special right triangle because of the 45-degree angle shown. So if you're trying to solve for x first, you want to set 7 equal to x square root of 2. Divide by square root of 2 on both sides. You're going to get 7 square roots of 2. Again, you want to rationalize the denominator, so you multiply by a power of 1. Why? Because this becomes square root of 4 that is 2. So that's where this 2 comes from. The top, however, is just multiplying 7 and the square root of 2. Kind of wrote this twice. But a square root of 4 is 2. That's where this came from. And so that goes away. 7 square roots of 2 divided by 2. They just brought this down to its decimal value of 3.5. Square roots of 2. So 3.5 square roots of 2 is one side length. So the whole side length is now 7 square roots of 2, because you would just be taking this and multiplying it by 2. So 2 of your diagonals divided by 2, these go cancel each other out. Just again note that the square root of 4 is 2. That's why that canceled out. 2 is going to cancel out. 2 over 2. So the area is 49. Your side length was already given to you as 7. So for perimeter, to get perimeter, you're saying 7 times 4, or 4 times 7, to get your perimeter. Number 5. The diagonal wasn't given to you, but a 30, 60, 90 triangle was. Across from our 30 degrees, they're telling us is a value of 3. So 2 times 3 is 6, gives us our hypotenuse, and 3 square roots of 3 gives us our value across from a 60, 30, 90 triangle. I know I went fast through that. Hopefully we've done enough of these you can remember. But look at the bottom of your chart for the values across from a 30 degree. Across from the 60 degree has this value, and across from a 90 degree has this value. Review special right triangles in order to answer this question if needed. So the diagonal, 3 and 3 is 6. 3 square roots of 3 is this one. So this little section right here is also 3 square roots of 3. Therefore I have 2 of the same. So common net, when you're adding, you leave the radicals as a common one, and these become 6 because you're just adding, not multiplying. So you now have your 6 and your 6 square roots of 3, your 2, 1 diagonal 1, and this was diagonal 2, and divide all that by 2. 8 square roots of 13. So if your side value is 6, then it's 6 times 4 that gets us to our perimeter of 24. Last one. If a rhombus has an area of 44 square centimeters and the length of one diagonal is 11, what would be the length of the other, I guess I should have said, diagonal? So this again is you're filling in what you know into the formula. 44 and 11, and we know we divided by 2. Well, dividing by 2, if you multiply by 2 on both sides, those 2 go away. You have 11 diameters 2 is equal to 88. Divide by 11, you get 8. So 8 centimeters is the diagonal 2. And that concludes 9-4.